Alright, let's find the derivative of h of s. Now, normally when I would find this derivative, I would use something called the chain rule, but it looks like we won't get to the chain rule till the next section in the textbook, so we got to do something else. So in this case, I would probably rewrite this. Since this is squared, that's like s cubed minus 2 times itself twice. And the reason why this might be helpful is now I can think of this using the product rule. Something times something. Alright, so the product rule says take the derivative of the first thing, and that would be 3s squared, times that by the second thing, plus the derivative of the second thing, times the first thing. A lot of repetition here since these are the same. And now we're just about done. So notice these are s squared times s cubed minus 2, and these are also s squared times s cubed minus 2. So if I've got 3 of them here and another 3 of them here, then I've got 6 of those. 6 s squareds times s cubed minus 2. So that would be what I get for the derivative. So before we move on from this one, again, I think it's going to be a little bit quicker to do the chain rule, which we'll talk about soon. But another alternative that you're welcome to do is you could have actually just squared this stuff. You could have said this times this gives me this. Means I'm multiplying it by itself twice. And then if you wanted to actually FOIL this out, you get s to the 6th minus 4s to the 3rd plus the 4. And then you could just use your power rules. Bring the power down, lower the power by 1, bring the power down, lower the power by 1. Derivative of constant is just 0. And then you need to see that this and this are really the same thing, because if I wanted to factor out a GCF here, these two are equivalent. So just a different approach. So if you feel more comfortable with this, feel free to go that route too.